Okay, so for this part of the exam review, we're going to review the cost function, and this goes back to optimization when we were finding the maximum profit or the maximum revenue. The revenue is the money that you earn per unit. The cost function is the money you spend per unit. And the profit function you get by doing the revenue function minus the cost function. And remember, anytime you see the word marginal, marginal cost, marginal profit, marginal revenue, that stands for the derivative of that function. Okay, so the cost of producing 100 units, we're going to plug 100 into the cost function. And using your calculator to solve, we get $806. Okay, the average cost is your cost function divided by the number of units, not the Q. So I'm going to take every term and divide it by Q. We're using X in this case. Sorry about that. So I'm going to divide so the cost function divided by the number of units for the average. So that's 800 over X plus 0.04. The X's will cancel, plus 0.0002X. And then it says their value's at 100. So I'm going to plug in 100. And we get $8.06. You could also take your cost function that you got at 100 and divide by the value of 100, and that's how we get the same answer. So now finding the marginal cost, I need to find C prime of X. So that is 0.04 plus, now 2 times 0.0002 is 0.304x. We're going to plug in 100. And we get 0.0004. Okay, for number 2, compare the marginal cost of producing 5 motors compared to producing the 6th. So the marginal cost is going to be C prime of X. But before I do that, I'm going to rewrite my cost function so it will be easier to find the derivative of. Because this is a quotient, I'm going to rewrite C of X to be 100 plus 50X plus 100x to the negative 1. So now when I find my derivative, the negative 1 comes down, negative 1 minus 1 is negative 2. Then I'm going to rewrite this without the negative exponent. And we want the marginal cost of producing 5, so C prime of 5. And that equals 46. Now, the cost of producing the 6th motor is the cost of producing 6 minus the cost of producing the first 5. That will leave you with just the cost of the 6th one. So if I plug in 6 to my original equation, I get $416.75. $3,267.67. We plug in 5 to the original, we get $370. And that is going to equal $46.67. Okay, the revenue function, if each calculator is sold for $18, the revenue for each unit is 18x. Profit is the cost, well, is the revenue function minus the cost. You have to be careful when you subtract the cost, because this negative gets distributed to all three pieces. And then we can combine like terms, 18x minus 6x. We get 12x minus 500 minus 0.02x squared. Maximize profit. That's asking for when P prime equals 0. So first we need to find P prime. That's going to be 12 minus, this goes away, it's 0, so 0.04x. I'm going to set that equal to 0. We're going to solve, and x is 300. So the production level would be 300 units. To find the maximum daily profit, I'm going to take 300 and plug it back into the original profit function. And we're going to get $1,300. Okay, so for number 1 here, which is the back of your paper, if the fixed costs are $10,000 and $12 per unit, the cost equation is 10,000 plus 12Q. The average cost is each term divided by Q. Revenue, we're going to earn $20 per unit. And profit is the revenue minus the cost. So the final profit would be 8Q minus 10,000. For part B, plug 1,000 into each equation and get your answers. Break even, that means that your profit equals 0, or when your cost equals your revenue. You can choose to solve either way. I'm going to set my profit equal to 0. Add the 10,000 over, divide by 8, so Q is 1,250. Okay, the cost of producing 100 units for number 2 here, plug 100 into the cost equation. We get $11,250. The average cost each term gets divided by X. plug in 100. We're going to get $112.50. Now for the marginal cost, that is asking for the derivative. And then we have to plug in 100. We get 130. Okay, so for number 3, there's 2 parts. First, we have to find the marginal cost of 100 ovens. So first we need C prime of x. So I took the derivative of the cost function. Now we're going to plug in 100. We get 116. Now the cost of producing the 101st oven is C of 101 minus C of 100. So we're going to take 101 and plug it into your original cost. Take 100 and plug it into the original cost. And we're going to get $116.11. Now there's a typo here in number 4 you need to fix. This quantity of it's saying the quantity for this situation can only be between 0 and 100. Fix that to say that the quantity can be between 0 and 800. Okay, find the quantity that will maximize profit. So first we have to find the profit function, which is revenue minus cost. And you have to subtract each piece of the cost function. We're going to simplify that, and we get 3.9q minus 0.003q squared minus 300. So to maximize profit, we need the derivative. So P prime is 3.9 minus 0.006q. We're going to set that equal to 0. And we have to solve for q. So I'm going to add that over to the other side. Divide by 0.006. So Q is 650 items. Okay, and for the last problem, the revenue, if a product sells for $5.88, the revenue for each unit is $5.88Q. Profit is revenue minus the cost. And remember, I'm distributing that negative to each piece of the cost function as I go. So negative, negative times negative, negative, and negative. Let's simplify any like terms. 588 minus 1,200 is negative 612 minus q to the third plus 60q squared minus 1,000. Okay, to maximize the profit, we have to find the derivative of p. Set it equal to 0. And I'm going to reorder this so that I have a nice quadratic. And I'm going to divide everything by -1. You can't divide by -1 until you set it equal to 0, because 0 divided by -1 is still 0. So I did divide by -1, divide everything here by -1. Now these are really large numbers to factor, so you can use quadratic formula, or you can factor it. Actually, everything divides out by 3. And then we'll have q minus 34 and q minus 6. So that means our quantities are 34 or 6. You have to plug both of those back into the original profit function, and we'll see which one gives us the maximum profit. So when we find P of 6, we get negative 2,728, and P of 34 is 8,248. So 8,000 is way more than a negative profit. Negative profit means you've lost money. So this is not our answer. 6 cannot be the production level to maximize profit. So we've got 34 items, and that gives us a profit of 8,248.